In this video, we show how to provide a context-free grammar for the language L is the set of strings W from the alphabet AB, such that the number of A's in W is less than or equal to the number of B's in W, which is less than or equal to 2 times the number of A's in W. So, first, let's think about what strings in this language look like. They do not have more A's than B's, and the number of B's can't be more than 2 times the number of A's. Okay? So let's first make a list of some strings that are in the language and some strings that are not in the language to get an idea of what kind of structure they could have. If the number of A's and B's is equal, which we know is allowed, we have strings that look like this. Okay, those kinds of strings. If there are more B's than A's, we can't have more than twice as many B's than A's. So if I have 2 A's, I can have 3 or 4 B's. So I could have A, B, A, B, B. So I have 3 B's. I could have 4 B's, B, 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 B. And order doesn't matter, so I could have B, 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 A, A, B, B, A, A, B, B. Yep. Okay, so these are some strings that are in the language. Strings that are not in the language. Anytime the number of A's exceeds the number of B's, A is not in the language. A, B is not in the language. A, B is not in the language. And anytime we have more than twice as many B's as A's, so A, B, 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 A. So you can see how this list is going to go. So we need to have some rules that create, so in these cases, okay, strings where number of A's equals the number of B's, we should have a rule that creates 1 A for every B that we create, and order doesn't matter. But we need to make sure that the A's and B's are not created independently, because when we're dealing with numbers being proportionately related in some way, then we need to make sure that we're keeping track. For every A we make, we're making so many B's, so they can't be made independently. So let's start off our grammar, and we'll come back to this list. Okay, we have our start symbol S. So we need to have a rule that makes 1 A for every B that we make, or really more because of the restriction, it makes a B for every A we make. So this rule will do that, starting with an A. And this rule does the same thing, starting with a B. So if we go back to these strings that I've kind of indicated, the first 2 strings are easy to make with our grammar. They're just one application. And actually we need one more rule, right? Because right now, with the grammar we have, even though it's not complete, it's never going to terminate. So I'm going to add a rule that can get rid of that start symbol so I can end a derivation. So if I apply S goes to ASB, and then I replace the S in the middle with an epsilon, then I have the string AB. And the same thing if I use the second rule instead of the first one, I get BA. So that'll give me those first 2 strings. So we've done these. Actually, I'm going to put it down here so we can kind of... Okay. How would I make ABBA? I could take S2, let's make it from the outside, ASB. And then here I'm going to replace this S with, which string am I trying to make? ABBA. Oh, we need one more rule actually to do this one. Our current grammar can't handle this. Why? The only thing I can do here is replace the S with either AB, which would make AABB, or it's going to make ABAB, right? So I can't get ABBA with my current grammar. So let's add another rule. Let's add that one. Okay, and let's go back and realize this derivation is not going to work. Okay, let's do S goes to SS. Now it's going to work. So let's replace the first S with ASB. So this is where the replacement happened. I'm going to do a leftmost derivation, so I'm going to replace that S with an epsilon. And now let's replace the second S with BA. And I'm actually going to do two replacements in one, just so I can fit it on this line. So I'm going to replace this S with BSB, and then replace the S with an epsilon. So I'm going to end up with ABBA. Okay? And you can see by using the rules in a different order, so here what I replaced was this, so it's very clear. If I use these rules in a different order, I'm going to get this string as well. Okay, ABAB, this is what I would have gotten had I not changed the derivation, so we can go, let's see, ABAB, ASB, and then we can go ABSAB. So here's where my replacement happened. And then if I use epsilon, ABAB. Okay? So that gets me this one. And you can see again, if I use the rules in a different order, did the same type of derivation, but used the other, just use the rules in the different order, I would get this string as well. Okay, and so we've done it for strings of size 2, strings of size 4. We can also do this for strings of size 6. So we just keep using these rules that make 1B for every A that we make, and we're going to get any string that has an equal number of A's and B's. Okay? So let's look at these other strings as well. This one, you can see that we can make AB, this first part of the string, but we can, right now can't make ABB. Okay, and actually this one we could do a couple different derivations, but what we need is we need a rule now that creates more than one B for an A. Okay, and how many B's do we want to create for any one A? Well, the number of B's has to be no more than twice the number of A's. So if I create one A, at most, I want to be able to create 2 B's, right? So then if I created 2 A's, I would want to be at most be able to create 4 B's. So really we have a 1-to-2 relationship. So let's add a rule that creates 2 B's for every A. So what if I have a rule that looks like this? Okay, if I just leave it as is, then I can only create I can only use this rule exactly once, and then I've replaced my S. However, if we allow this, now every time I use this rule, I have the option of going back and using one of the other rules I already have. So let's say I have 3 B's and 2 A's in my string. I can apply this new rule and then insert AB or BA into either location where we have an S. Okay? So with this rule, ABB, I'm trying to keep track of the rules I've made. Let's try to make this new string. There's a couple ways that we could do that. Let's make the easy one. If we go to SS, and then I use, I'm going to use the rule ASB to replace this first S, but I'm going to skip a step and then replace that with epsilon, just so we have less writing here. So I would end up with ABS. Okay, you see what I did? I used the rule ASB and then replaced that S with an epsilon. Okay, now I could use our new rule ABB to do, we're going to do AB, and then I'm going to use the rule, I'll just write it out long ways this time, ASBSB, and then I would apply with some epsilon rules to get rid of those S's. Okay, and that's going to give me the string. Now, we don't always want, do I have a string that looks like this? Let's add some strings to our in list. Let's add the string BBA. Okay, I claim that no rule we have right now will make that string, even though that string should be in the language. Right? So we can't figure out a way to use our existing rules to create that string. So we need to add a rule that will handle that. And we're going to do it like the last one we did, where we allow, where we're going to allow another rule to be added to either one of those we're going to add another rule to be used to replace any of these S's so that we could insert like A, B, or BA inside. Okay? So now this rule is directly going to allow us to create the string. Likewise, if I have BAB, I claim we can't make that with our existing rules. There's no way to do that. So let's add a rule for that. So we're going to again do it this way. Okay. So now we can create the string. And I claim that's all we need. So, for example, let's look at our rules. If I have, let's say I have 2 A's, 3 B's. Okay, I'm going to use one rule that's going to give me like 1A and 2 B's. So I'm just going to keep track. So I've got 1A and 2 B's. I'm going to use one of those kind of rules. Okay, and then I'm going to use a rule that gives me 1A and 1B. Okay, and that's going to give me the 2 A's and the 3 B's I need. And in any order. Because notice all of our rules are permutations of the other rules. So we have ASB or BSA. So no matter when this kind of rule here, no matter which order I need it in, I'm going to get it because I have a rule in each order. Likewise here, whether the A occurs at the beginning, middle, or end within this set, I'm going to get that. So if I have, say, 2 A's and 4 B's, what am I going to do? I'm actually going to use 2 of the rules that gives me 1A and 2 B's. That gives me 2 A's and 4 B's. If I have 3 A's and 5 B's, what am I going to do? I'm going to use 2 times the rule that gives me 1A and 2 B's. So we're now going to have 2 A's and 4 B's. And I'm going to use one of the rules that gives me 1A, 1B. Okay, let's just do one more. If I have 4 A's and 5 B's, if I use, how should we do that one? If I use 3 of the rules that give me one A and one B. I now have 3 A's and 3 B's, so I need one more A and 2 B's. Well, I have a rule that gives me that. 1 A and 2 B's. Okay, so I claim that this will make every string that's legal in the language, and it won't make any that aren't legal, because if we look back at our non-legal list, there's no way to create 1A, so we're safe here. There's no way to create more A's than B's, so we're safe here, and we're safe here. And for every A that we make at most 2 B's. So I can't make 3 B's with an A, and I can't make 4 B's with an A. Okay, so we haven't violated any of the rules of the language. So let's just do maybe 1 or 2 more of these derivations to show that we can do everything. Okay, so I've got 2 A's and 4 B's, so I need to use 2 of those rules that give me 1 A for every 2 B's. So how about we use the rule that basically creates ABB, and let's do that twice. So let's take S2 ASBSB. Okay, and now what I really need is I need AABBBB. So I need another ABB inside. So if I do AASBSB, this is what I replaced. I replaced this S. And then I have to tack on what I already had, BSB. Okay, now I've got, if I apply all of the rules that turn S into epsilon, I'm going to have AABBBB. Okay, so I got this one. BBBBAA, you can see we're going to do it the same way, but we're going to use the rule that gives BSBSA, and then insert it at the end, right? So you can work that one out. That one's going to work. How about BBAABB? I claim that there's a couple ways to do this one, but there's one easier way. So if we just make SS, we replace the first S with the rule that goes BSBSA. So here's what I replaced. I'm going to turn these 2 S's into epsilons, the first 2. So I've got BBAS. Okay, you can see we're halfway there. Now I'm going to use the rule, but I'm going to put it down here. BBA. Now I'm going to replace this S with ABB. So really it's ASBSB. I turn those S's into epsilons. So here I've really done more than one. I've taken more than one step. I'm going to have BBAABB. Okay, and that gives me that string. So I claim that this is a grammar for this language.